The Magneto-Rheological Abrasive Flow Finishing, or MRAFF, is a hybrid process of abrasive flow machining, that is AFM, and magneto-rheological finishing, that is MRF. So in short, it maintains the versatility of AFM process and at the same time the controllability of the MRF process. Let's see the abrasive flow machining process, in which it uses abrasive grains mixed in a viscoelastic polymer matrix, and it is made to flow or extruded over the material or the work surface from which we have to remove the material, and by moving through that material, the abrasive grains which abrades the surface or bursts from the specific surface of the material. On the other hand, the MRF process relies on a unique smart fluid which is known as the magneto-rheological fluid, or MR fluid. These MR fluids are suspensions of micron-sized magnetizable particles such as carbonyl ion particle, commonly known as CIP, which is dispersed in a non-magnetic carrier medium like silicon oil, mineral oil, or water. The phenomenon of magneto-rheological effect can be explained with this figure, and in figure A it shows that in absence of magnetic field it behaves like a Newtonian fluid. On application of an external magnetic field, as in the figure B, this H is the applied external magnetic field, the CIP, that is the carbonyl ion particles, which are aligned along the path of magnetic field lines in this direction, and by aligning this like this, it encompasses the abrasive particles, and it is also aligned along with this magnetic field lines. And in this condition, if we apply a shear strain in this direction, the fluid exhibit a resistance to this deformation caused by the shear strain, and it's the intensity of this resistance depends on the strength of the applied magnetic field. And when this field is removed, the fluid again brought back to the initial stage, that is, again it will show the characteristics of a Newtonian fluid. When we use the MR effect for finishing, it is known as a MRF process, and the setup is shown in this picture. And here, wherever the machining is required, there we are providing the magnetic flux, and that portion of the MR fluid gets stiffened and the machining is happening over here, and the remaining portions where the magnetic field is not applied, they are still remained as Newtonian fluids, and no machining is happening over these regions. In MRAFF process, the MR fluid is extruded back and forth in this direction, back and forth, through the passage formed by the workpiece and the fixture, just like as in AFM process. And then the magnetic field is applied across the regions where polishing is required, keeping the other areas unaffected. The MR fluid is get stiffened on the regions where the magnetic field is applied, and the machining or abrasion is happening on that regions only. The viscosity of the MR fluid is a function of applied magnetic field strength. Thus, the finishing characteristics of the process can be controlled by varying the magnetic field strength. The application of this process can be seen in all modern industries like automotive, aerospace, robotics, medical field, optical instruments, and metrology. Thanks for watching.